So question number 15 related to standing wave assignment, related to the waves assignment. And like ready meals that can be heated in a microwave oven always have instruction that the food should be stirred properly before eating. This is because of hot and cold spots within an oven, which leads to uneven heating of the food. Why actually there are hot and cold spots within the food in a microwave oven? The reason is that because as these waves reflected from different positions and meet at certain points, so some position they may have a part difference of wave one wavelength, two wavelength, or zero wavelength. As a result, zero, it won't be zero in this case, as it's obvious, like it should be multiple, not zero wavelength, as they did not travel the same distance. So it will be one wavelength, two wavelength, three wavelength. So as a result, there will be a constructive interference or will have a maxima. But what might happen, maybe some other points which are also known as the cold spots. What might happen, what leads to formation of these cold spots? That the part difference might be equals to half wavelength, 1.5 wavelength, 2.5 wavelength. So destructive interference which leads to cold spot. That's why the food must be stirred. So as it might lead to uneven heating due to the formation of the hot and the cold spots. Explain what is meant by the following words. Coherent. So you have to learn this definition of a coherent. Coherent means that when waves of constant phase relation, we call that as a coherent. Like if one wave is produced, there's a crest, the other wave is also a crest. So the waves with constant phase relation are known as the coherent. Then what is the definition of a standing wave? The definition of a standing wave is the wave which is produced by, like, the pattern nodes and antinodes are produced, or there are points of maximum displacement and minimum displacement, or the wave which does not transfer, no net energy transfer is there. So the wave which there is no net energy transfer, which is produced by combination of two waves, so the wave which is produced by combination of two waves traveling in opposite direction or moving in opposite direction, result nodes and antinodes, or no net energy transfer. So that is known as the standing wave. The next question, the diagram shows the path of a two microwave which are arriving at point S. So the two micro and the wavelength of a microwave is 12. So they meet at point S. We want to identify whether, explain why at S there will be a cold spot. So first what we do, we will work out the part difference. So for first wave, first it travel 18 and then travel 6. So 18 plus 6, that's equal to 24 centimeters. So first wave travel 24 centimeter from the microwave source till the point S. And the second wave travel 30 plus 12. So it means it travel for, because as you can see here, 30, then bounce back and 12. So 30 plus 12, that's equal to 42 centimeter. So if we work out the part difference between them, it will be 42 minus 24. So this 42 minus 24 will give us the part difference that is equals to 18 centimeter. And what is 18 centimeter in terms of wavelength? Like if one wavelength is equals to 12 centimeter, if we have a 18 centimeter gap between the two waves, what will be the part difference? So it will be simply 18 divided by 12. It's equal to 1.5 wavelength. So whenever the part difference, when we work out, it's 1.5, 2.5, 3.5, or even 0.5. So what kind of interference we have? We'll have a destructive interference, and destructive interference means the two waves will cancel out the effect of each other. So mark distribution, 1 mark is for calculating the like 2 marks are actually for calculating the part difference. Then mentioning at this point the two waves when they interfere, there will be 180 out of phase, or there will be a destructive interference, or they cancel out the effect of each other. 2 marks for the part difference, 2 marks for the explanation. So question part C, uneven heating can be reduced by placing a food in a rotating turntable. Explain why this will reduce the uneven heating. Because look what happened. Say if there was no turntable in the microwave oven, so we will have fixed position where we'll have a cold spot and we'll have a hot spots. So as a result, what will happen? Uneven heating is there. But now, as a in a microwave oven, when we place a food, it's on the turntable and it rotate with a constant speed. What is the advantage of placing it on the constant on the turntable? As a result, what will happen as a food will, like different parts of the food will move through the hot and the cold spot, so they will receive the same amount of energy. So it will make all the food will have an even temperature. But what if there was no turntable in the microwave oven? Then there will be more uneven heating as a result of the hot and the cold spots. In question 16, the wavefront of a light changes shape when they passes around the edge or through the slit. This means the light bends and effect is called diffraction. The longer wavelength of a light diffract, like longer wavelength diffract more than shorter wavelength. As we discussed, like wavelength is comparable with a gap size, it will have a maximum diffraction. The diagram on the left shows the red light passing through a slit undergo diffraction. On a diagram show on the diagram on the right show the same effect for blue light. So when we compare the wavelengths, we have violet, indigo, like we have violet, indigo, blue, green, yellow, orange, and red. Red is having the highest, the longer wavelength in the visible region, and violet is having a, so we, as a result, what will happen when we move from red to blue, the wavelength decreases. Longer wavelength, as they already mentioned in the question, that longer wavelength diffract more than smaller wavelength. So as a result, because blue will have a smaller or shorter wavelength, it will have small diffraction. So less diffraction, how we represent? Only the edges slightly curve or bend, and this is a small diffraction. This one curve, completely curvature, representing a large diffraction. And why there's a small diffraction? Because the wavelength of a blue is shorter than the wavelength of red. If the red light passes through two slits, they're closer to each other. The waves spread out, overlap together to produce a pattern of a light and a dark band or a fringes. Complete the diagram to show how overlapping of a wave produce a pattern. So this is one from one, and this one is from, because maximum diffraction. So the points or the position where they meet, like these spots, constructive interference. This is spot, constructive interference. If I continue, this is spot, constructive, constructive. Like these are representing the crest. So all these, they have a constructive interference. And how we represent a destructive interference? Because like these are the wave fronts, so they're representing the identical point. Between them, the dotted line, like it, like if this is representing a, these wave fronts are representing a crest, so the dotted line is representing a trough. So where the trough meet with the crest, there will be a destructive interference. So example, a constructive interference I'm representing by the black spots, and destructive interference I'm representing with a blue spot. So at this point, you can see the crest joined with the trough, so destructive interference. This point, crest joined with the trough, destructive interference. This point crest joined with the trough, destructive interference. Destructive interference. This point also destructive interference. And where crest joined with crest or trough joined with trough, constructive. So this will be constructive. This will be constructive. So you have to mark these points and label them as a constructive or destructive interference. One thing you have to keep in mind, like this gap, it should be with, as it's a 4 mark, the wavelength does not change. So this, say this was 2 centimeter. So when you draw these curve, this should also be 2 centimeter apart, because the wavelength of a wave does not change as it's not changing a medium. If there was a change in medium, then the wavelength will change. Then the spacing between the two dark band in pattern produced is inversely proportional to distance between the slits. Like what they mean here, say we have this, the screen is there, and we have dark patterns, bright and dark fringes are there, the lines. So they say this distance, example, say the spacing between the slit is spacing between the lines is inversely proportional to spacing between the slits. If we have, like example, if we reduce this gap, the spacing like will increase. Like this gap, if we reduce the gap, like this D is in reduced, then this spacing will increase between the two slits, between the two fringes. If we increase this, this will decrease, opposite. So they mentioned the spacing between the two dark band produces inversely proportional distance between the two slits. The red light is shown through two slits. They are separated by 1 millimeter distance. The dark bands pattern are 0.6 millimeter apart. How far the pattern of a dark band would be if the distance between the two slits reduced to 0.4? When two quantities are inversely proportional, the product is constant. Like if I say distance between the two slits is x, distance between the two dark fringes is x, and the distance between the two slits is d. So x and d are inversely proportional. Or when two quantities are inversely proportional, the product will be constant. So I can say x1 d1 will be equals to x2 d2. Like the spacing between the band, the fringes, and this is a spacing between this slit. The product of this one will be equal to the product of other. Here I don't need unit conversion. So I have 1.2 here. This is 1.2, the distance, and the gap is 0.6 equals to how far the dark band we need x2, and the distance is then 0.4. So we just simplify this. So it will be 0.6 times 1.2 divided by 0.4. So this will be 1.8 millimeter. So that's equal to 1.8 millimeter. As I did not convert the unit, so it will be 1.8. So whenever two quantities are inversely proportional, the product between them is constant. Then we have to describe the effect on a pattern if a distance between the two slits gradually increase to 1 centimeter. As we know, like the distance between the slits is inversely proportional to the distance between the slits is inversely proportional to the distance between the fringes or the lines on the screen. Like bright and dark fringes or lines are there. So this distance is x. They are inversely proportional. They are saying, what describe the effect on the pattern if two slits we increase. So if I increase this, what will happen to this pattern? So the fringes will come closer, so the gap will become narrow. Like these fringes will come closer to each, and eventually they will overlap. Like all these fringes will come very close to each other, and eventually there will be overlapping between them. So you have to mention that the distance between the lines decreases. and eventually they will overlap.